Hello pre-calculus student, this video is for chapter 6.2 part 2. We're going to talk about how to graph a general sine and cosine function that involve also horizontal and vertical shift by not just a sine bx or a cosine bx, but minus c or plus d inside the input or outside. In the last video, we talked about how to graph a sine bx and a cosine bx, where a would be a vertical shift that changed the amplitude, and b would be changing the period where the graph does not stop at 2 pi, but 2 pi over b. Now, if I have a minus c inside the function, it would amount to horizontal shift, also known as phase shift in trig function. Then the amount of phase shift is c over b. Okay, remember this c is not factored out. It is bx minus c. Okay, vertical shift would be the d that is outside. So if you plus d, then there is a vertical shift. Oh, there's a typo here. Vertical, vertical, oh, vertical shift. That means up or down. Okay, up or down. So let's experience this in a decimal graph. So for example, if I graphing sine and cosine, so let's do a sine function. And then I want to do sine x minus pi over 4. You will see that it's moved, right? So the purple one is the original sine function that has the, if I off it, you can see that it stopped at 2 pi sine from x-intercept, go up, down, back to x-intercept, and then go down, back to intercept. So the period is 2 pi, but if you minus something, it's going to move to the right, right? So let's see how. Move to the right by pi over 4. If I add, it will move to the left by pi over 4. Okay, so, but if it is 2, what happened? If I have 2, the original function, just say 2x first. If I don't do that, you will see that it actually go faster, right? It complete the whole cycle to pi. But then if I do pi over 4, it would have a pi over 8 shift. Why? Because it would be pi over 4 divided by 2. So the phase shift is always about this number c divided by b. And sometimes in other book, they would do it as a factored. So the actual phase shift is pi over 8 if you factor it. Okay, so if it is not factor, you would have to divide it by the b function. Okay, so this would be the same thing. So, oh, maybe I'll just show you how it's different. Okay, so make sure that you know x minus pi over 4. So this is, oh no, 2. The x has to be inside. Pi over 8. So you can see that they are both the same. Okay, if you don't, okay, so yeah. Right, so they're actually the same thing. So 2 parentheses x minus pi over 8 is the same as 2x minus pi over 4 because the phase shift, if you factor, is really pi over 8. You see how the functions start later at pi over 8. Whereas here, we don't start at pi over 4. We do start at pi over 8 because it's pi over 4 divided by 2. See the difference? Okay, so at the book here, usually just write 2x minus c. So the actual phase shift is the c over b. If your c is actually inside the parentheses of b, then this is actually the phase shift, right? Phase shift. If I do pi over 2, this would be, this will shift pi over 2, right? Oh, well, pi over 2 is not very good. Okay, so it will shift pi over 4, right? Or if I say pi over 3, it will shift pi over 3. Okay, add will shift it sooner, pi over 3 to the left. Okay, so start like this. Okay, so this is how you should understand. Now, what happens if I don't do this, but just do y equal to sine x and then plus 5? So this plus 5 would be outside. So the whole graph will shift up, where the midline now is the y equal to 5. So anytime you shift up, the midline also shift up, the amplitude don't change, right? So if I say 3, the midline is still 5, but you will fluctuate from 5, 3 up and 3 down. Okay, so let's go back to the notes to go about graphing it. So if I see a x minus pi over 4, I know it is shift to the right by pi over 4 because there's no number in front of it. The amplitude is the outside number 1. There is refraction because I see a negative number. The period is still, so b is still 1, so it is still b equal to 1. It's still 2 pi. Okay, so remember, period is 2 pi over 1 or over the b. So 2 pi over b. Period is not 1. Okay, that means in this whole circle you have 1 cycle. Vertical shift is the number that add and subtract. So there's nothing, no vertical shift. Phase shift is the c that you see. Okay, pi over 4 because b is 1, so it's just pi over 4. And the direction is to the right. Minus means to the right. So if that is the case and I don't have any vertical shift, then the maximum y is 1, minimum y is -1. So I can just dot it the horizontal and vertical. I know the graph would have a midline at y equal to 0. This is y equal to 0 is the midline. Okay, so if I start at pi over 4, phase shift is pi over 4, right? Then I will start at pi over 4. And it will end at what? Doesn't end at the period. It's end at 2 pi plus pi over 4. So the period at the phase shift is where the basic cycle ends. So this means 9 pi over 4, right? So you will say this is pi over 4 for sine. You start. And then you have, what is the middle? So you have 5 pi, 2 pi. So this is pi over 4. This is 10 pi over 4, so this must be 9 pi over 4. So the middle of it would be this one. It used to be pi, now you shift pi over 4. So this is another x-intercept. Because I have reflection, I will go down in the middle. So this is, this is in the middle. Go down first, and then go back up. And this is the quarter point. Go up and then go down. So of course you can just continue. Okay. So that is how you graph x minus pi over 4. Wow, this one. So this is a number outside A, B, C. Okay, so amplitude is absolute of A. That is equal to 3, and there is no reflection because the actual A is positive. Period would be 2 pi over this B. Okay, not the C here. 2 pi over B. This case would be 2 pi divided by pi over 4, meaning 2 pi times 4 over pi, that is equal to 8. So it should start at 0. So I would just take a note myself. 0 to 8 is the old one. But what is the vertical shift? There's none, right? Because I don't see any add and subtract. So the midline is y equal to 0. So this is y equal to 0. And I know the maximum would be 3. The minimum is -3. I would dotted it to know that this is the wave, the sine and cosine wave will not go up or down exceeding these two lines. The phase shift would be C over B. In this case, we see C is pi over 4, B is also pi over 4. That is equal to 1 and is on the right side because we do subtraction. Okay, subtract is right. So the old one before phase shift is 0 to 8. After you do right one, it would be 1 to what? 8 plus 1 equal to 9. So it should used to be 0 to 8. Now you plus 1 plus 1 will be 1 to 9. Okay, so that means I have 1 to 9. The middle of 1 to 9 is 5. This is a sine, so it's like up. No reflection, so go to 3, down to 3, like that. Right. Okay. 1, 2, 3, 4, right? Oh, no, too much. 1, 2, 3, 4. 1, 2, 3, 4, right. So it should be like that for 2 cycles. Okay, go a little bit higher here. Right, so we have 2 cycles like that. And remember, the phase shift will make the basic cycles that used to start from 0 to 8, now it become 1 to 9. Okay, see, we'll sketch a graph of -2 cosine x plus 3. So this is A. It affects the amplitude. 3 is push the midline to y equal to 3 become the midline. Is the middle of the graph would sit at y equal to 3. So I'm going to do 3 here, just freehand, y equal to 3 because it's up 3, right? So the maximum, if the amplitude is 2, absolute of -2 is 2. So the maximum will be from 3, you go up 2, so it's 5, right? 3 plus 2. The minimum will be from 3, you go down 2, so it's 1. So I would say, oh, okay, this 1 is too small. 1, 2, 3. Oh, so be like that. And then the maximum is 5. So this is what the loop would be, right? Would be switch around here. The phase shift, do I have any B and C? Nothing. So phase shift is 0, period is 2 pi. Guess there's nothing to divide. B is 1. So that means you will start from 0 to 2 pi. So I will write 2 pi here, or 2 pi here, and this is pi. This is pi over 2, and that one is pi over 3 pi over 2. So, but the intercept, because this is cosine, right? So it start off at the highest point, go to the midline, go to the lowest, go to the midline, and go to the highest point. So that's how I graph the cosine. Oh gosh, it's negative. So I need to. I forgot the reflection. If there's a reflection, reflection for cosine should be like this, right? So start from the lowest, in this case is 1, the midpoint, at the quarter point it go back to 0, and then it go up to highest point, go to the quarter point, and go back to this. So, but don't make a big V. So this would be concave down, this is concave up, like that. So they would go on forever. Okay? Oh, what is the domain and range? The domain is, you can see this real number, it can go on forever. The range is between 1 to 5, right? Between 1 to 5. Did I do domain and range? No. Okay, so you can also graph this by the calculator. So if you go to a TI graphing calculator, I'll show you how to do. You would do y equal, okay, clear this. What do they want? Let's say sine x, right? So you do, if you graph this, you need to change your mode back to radian. Okay, change your mode back to radian and then do y equal. Oh, okay, so got this clear. Sine x. So suppose I want to look at how sine x look like. And then I do, so this is y equal, and then I just do sum trigonometry 7. Right? So you can also do the tick mark to see the x minimum is negative 2 pi. This is x maximum is 2 pi. And then 1.57, I think it's pi over 2, pi over 2. So if you graph it, it would look like this. So each tick mark is, this is pi over, can I zoom in? This is pi over 2. Zoom. Okay, so you can see that this is pi over 2, this is pi, and the n is 2 pi. So if you want to change it so you can get more thing, you can do window. You can say, oh, I want to do negative 12, negative 12.4. Then you can have more, oh, okay, minimum, and then this is 12.4. 12.4. You can also do 2 pi or 4 pi. Oh, I can just show you this instead of, you can say 4 pi, right? 4 pi, yeah, 4 pi is 12.56. Then if I do graph, okay, so don't do zoom, so you will see that it would have more period, right? And this is pi over 2, this is pi over 4, like that. You can actually change the window, but after you change the window, so you can say negative 2, where's pi? Pi is here, pi. Oops, sorry. Pi is this one, right? Yeah. See, negative 2 pi. Press enter, it becomes negative 6.2. If I do graph, you see at negative, they have only one cycle, but this would have 4 pi. Okay, so can use it this way. Do some trick. Zoom trick will adjust everything so each tick mark is a pi instead of 1, 2, 3, 4. Okay, so let's go back. So that's how adjust the period of or the amplitude if needed in Windows. Relationship between A, B, C, D and characteristic of sinusoidal graph. So this is how you can figure out if you see a graph, if you see a function or a graph, how can you write a sine or cosine function? So maybe I'll talk about this in the next video. This will be covered further in Math 187, but I'll talk about it here. But we won't test this in our course.